All right, we're going to take a look at number 3 here. I'm sorry, number 2 right here. We're going to look at what happens when we change the temperature. What happens to volume here. So this first problem here, we're given an initial volume of 14.3 cubic meters, and we've got a temperature of 62 degrees Celsius, but we want to change this to Kelvin by adding 273 to it. So if we do that, we should end up with a new temperature of 335. That should be an equal sign. Sorry, 335 Kelvin. And if we look at our new volume, that's what this problem is trying to get us to find. When we change our temperature to 24 degrees Celsius. And again, change that to 273. And we're going to end up with 297 Kelvin. Alright, so we're going to use the formula V1 over T1 is equal to V2 over T2. This problem is asking us to solve for V2. So if we rearrange this equation, we end up with V2 is equal to V1 times T2 over T1. And let's plug the numbers in here. We've got 14.3 meters cubed times, let's see, 297 Kelvin. That's a 9 there. All divided by our T1, or 335 Kelvin. When we do the math, our units for Kelvin are going to cancel out, and we should be left with 12 point. I found when I used sig figs, it just gave me 12.7 instead of 12.6, but close enough. All right, so that's how we do number 3. Let's skip down. Let's try another one that's a little bit more difficult. Let's take a look at number 5. So it says calculate the mass. So we're going to be looking for mass of 162 liters. That's a volume of chlorine gas. So chlorine gas, that's Brinkelhoff. We got Cl2. So our molar mass, wouldn't be a terrible idea to know what the molar mass is. Not really sure if I need it yet or not. But our molar mass for this is going to be 70.90. Just twice the mass of chlorine. That's going to be grams per mole. So 70.90 grams per mole. Measured at STP, so that's standard temperature and pressure. So our temperature is going to be 273 Kelvin. And our pressure is 1 atmosphere. I don't know why this is doing this. Pen's getting all crazy on me. But anyway, so the only other thing, let's see, I've got a bunch of P's and T's and N's and, well, no M's, but M's, molar masses and volumes. None of these are changing, so this is what we call a steady state problem. We're not changing any temperatures or pressures, so none of these will be V1s or P1s or T2s or anything like that. The only other piece of the puzzle here for these steady state problems, we're going to use R, and that's going to be 0.0821 liters atmospheres per mole Kelvin. So we're going to use a formula that's going to involve all these. And the formula we'll use in our reference book is molar mass is equal to our mass times R times T over PV. And if we rearrange this to get M all by itself, we're going to end up with molar mass times PV all over RT, and set that equal to our mass. So when we plug everything in, mass is equal to 70.90 grams per mole times our pressure, 1 atmosphere, times our volume, which is 162 liters, all over our R, our gas constant, 821, times our temperature, 273 Kelvin. And when we do this, we should end up with 500. I get 512.